class, welcome back. Today we're going to be doing lesson 80, which is transformations. We talked about this a little bit before we left school because we did reflections. Remember when we drew one triangle and then put it on the other side of the x-axis or y-axis? So we did do a little bit of this, but today we need to kind of like get into depth and make sure we know everything that we need to know about transformations. So first of all, a transformation is an operation on a geometric figure that alters its position or form. So either it's moving somewhere or it's getting bigger or smaller. That's what that means, it's position or form. The first one, which we've already discussed, is a reflection, which is a flip over a line. As you can see, this is reflected about the y-axis. Obviously, if they said x-axis, it'd be down here. But since it's y-axis, they just flipped it over the line. I'm not going to sing the song about reflection, but when Mulan looks into the river or the pond or whatever, she sees her face looking back at her. That is what a reflection is. The next type of transformation is a rotation. So this figure is rotated 180 degrees. So it was up here, and then it turned and became down here. And it's rotated 180 degrees. Do you see how point B is 180 degrees away from each other? Same thing with A and same thing with C. The 2 points form a 180 degree angle, which is a straight line. So that's a rotation. And then a translation is just a slide or a move. Remember, I took the podium and I moved it over. Basically, this is just 5 units to the left and 3 units up, and they did it to every single point. Remember when we draw a new, the image, the new point gets a little prime with it, just kind of to say, this is the original and this is the image. So that's the introduction. We're going to jump right into some examples and make sure that we know how to do all of this. We're starting with a triangle, and the points are at 4, 3, 4, 1, and 1, 1. So remember, over first and then up, 4, 3, 4, 1, and 1, 1. You're just going to have to bear with my crooked lines. Okay, so this is RST. This is our original, so there's no primes. Now, it says graph the triangle and reflect it about the x-axis. So, as we should know, this is the x-axis. So we're not putting it over here, we're putting it down here. So basically, we just go to the points, and T is 1 away, so we put it 1 away on the bottom, that becomes T prime. Same thing with S, S prime. And then R is 1, 2, 3 away, so we go 1, 2, 3 away. Hold on, I always mess things up, so I think that's correct. So we have our new triangle, which is a lot straighter than our original. And we put little primes on it. That's literally all there is to reflections. The only weird thing is if you ever have something on a line, when you reflect it, you just keep it on the line, if it's the line you're reflecting it about. So don't get confused if there's something on the y-axis and they said to reflect it around the y-axis. You just keep the original point because it's 0 places away from the line. Hopefully that makes sense. Let's move on. Rectangle ABCD, so now there's 4 points. It's at 4, 3, 4, 1, 1, 1, and 1, 3. So I'm just going to quickly okay, so that's our original rectangle. Well, I guess I'll try to draw the lines. I just can't seem to draw straight. Please bear with me. I ask every day of my life as I'm teaching. Okay, so ABCD, and this one is translated. So translated is when we just move it. So they want us to move it 5 units to the left and 4 units down. So we're just going to take every single point and move it 5 units to the left, and 4 down. Wait till you're at your final destination before you write the new dot. Don't go 5 and write a dot and then 4 and write a dot. So is that 5? 1, 2, 3, 4, 5. 1, 2, 3, 4. So that's C prime. D is going to be the same thing. 1, 2, 3, 4, 5. 1, 2, 3, 4. And then A, 1, 2, 3, 4, 5. 1, 2, 3, 4. And at this point, we can tell where B is going to be. Oops. So these are congruent rectangles. They're the same exact thing. We just moved it. And that's all there is to reflection. I mean, translations, you just move it however many places to the right or left or up or down or whatever they ask for. So this is how we do a translation. This is the hardest one. The hardest one is the rotation. In your book, they're going to say take transparency paper and then flip it and do 90 degrees. You can do it that way, but that was always like more difficult. So instead of doing it that way, there's a mathematical way you can find the new coordinates, which is what we're going to do. So it says the original vertices are at 3, 4, that's P, 3, 1, that's Q, and 1, 1 is R. Make sure I'm right. 3, 4, yep, okay. It's hard being left-handed with these things because every time I put my hand up, it blocks the light. I'm not laughing. Okay, that's PQR, that's our original image. And they say to rotate it counterclockwise 90 degrees about the origin. So that's kind of what's understood, that it's about the origin and that it's counterclockwise. So when they say rotate 90 degrees, switch X and Y. So 3, 4 becomes 4, 3. Right? And then after you switch X and Y, change the sign on X. It was positive, now it's negative. So your new one, your new P is going to be at negative 4, 3. So 1, 2, 3, 4. 1, 2, 3. And that's your new P prime. Now Q is at 3, 1, so that will become 1, 3, and then negative 1, 3. Hopefully you're following. So negative 1, positive 3, and then R was at 1, 1, so it'll end up being negative 1, 1. Okay, so let's connect these dots. Hopefully you can hear me. And does it not look like it was just tipped over 90 degrees? Right, a right angle. And all of these, all of these points have just been moved 90 degrees. And that's all that it is. So anytime you got to do 90 degrees, switch X and Y, change the sign on X. For 180 degrees, all you have to do is change the signs on X and Y. So keep that in mind and go back, and of course if you're taking notes, write that down. But that is a rotation. Now, we've talked about all of the situations in which we move the figure. Now we're talking about when it changes forms. A dilation is a translation in which the image grows larger. Have you ever gone to the doctor and had to get your pupils dilated? That's exactly what's going on here. Your pupils get bigger, the image gets bigger. So these are not congruent triangles anymore because they're not the same size, but they are similar triangles because they're still the same shape. So just a little bit of vocabulary checkup that you understand the difference between congruent and similar. So this is the original, and then it just got bigger. Now, if we are making it smaller, that's called a reduction. Just letting you know, reduce means smaller, so that's easy. So when you know the scale factor, all you have to do is multiply the coordinates by the scale factor in order to find the new coordinates, and we'll do an example so you understand. So triangle XYZ is at 1, 1, 2, 1, I'm going to do it correctly, and 1, 2. So it's a tiny little triangle. Okay, X, Y, and Z. Graph X, Y, and Z and its dilation, so it's going to be bigger, with a scale factor of 3. So we're thinking, remember how when we do ratios, we just multiply everything by the same number because they're proportionate? Same thing with this. If the original is 1, 1, and the scale factor is 3, we multiply by 3, and so now the new coordinate is 3, 3. And the sides over here are 1 unit, but they're going to be 3 units now because now the sides are getting 3 times bigger. So hopefully that makes sense. If the new X is at 3, 3, it's going to be up here, 3, 3. And then the new Y is going to be at 6, 3. And the new Z is going to be at 3, 6. So the new sides are 3 units long, because these were 1, these are going to be 3 because it's times 3. And you have the same triangle, only bigger. So these are similar, not congruent, because remember, similar triangles have the same angles, but their sides are proportionate, not the same. That's exactly what we're doing here. The scale factor is 3, so we times 3, and that's how we get our new points, and we graph our new triangle. Don't forget to put your images, in your image, don't forget to put the prime symbol to show that it's an image. I think that's the last example. So that's all. So if you have any questions, comment, let me know, and I'll help you through it. Go back and watch the video, and good luck. Thank you.